Hello everyone. I hope that you are staying safe and I hope that your summer is going well. I'm actually very excited to have you back on campus this fall. I know that you're also very excited to be back on campus, especially to meet with your friends. Obviously, we missed you guys in the second week of the second half of the spring semester and also throughout the summer. So it would be nice to have you back on campus. So I also wanted to record this video to tell you little bit more about the class that I'm teaching in this fall semester. So if you may know, I'm teaching an upper level class that is called Introduction to Geophysics. As per the new curriculum, it is called as Environmental Geophysics. So this is a 4 credit class. So for this particular class, the prerequisites are Geology 110 and Math 119. So what this class is about? So in this class, I'll be giving like a brief overview of various geophysical techniques that people use, especially in environmental and geotechnical industry. So if you go to like indeed.com and if you look for geology jobs, especially in this area, you'll see that there are like a lot of jobs, especially in like hydrogeology, but also like in environmental and geotechnical fields. So some of the skills that are very common in these fields are basically a good understanding of these geophysical techniques and learning how to like go in the field, collect data, interpret the data, and solve the problems. So that is something that we'll be focusing on in the fall semester as well. So in this class, I will basically focus on four main groups of techniques. So starting with potential field methods. So if you have taken physics class, you may kind of like know about gravity and magnetism. So especially in the mining industry, when people are looking for mineral resources like gold, copper and other metals, a good understanding of those mineral resources in the subsurface can be developed by interpreting data sets like gravity and magnetism. So we'll kind of like learn a little bit more about like how these potential field methods can help you identify those resources in the subsurface. But also when you think about tectonics in general, like like big scale problems like plate tectonics, gravity is one of the gravity and magnetism. These are like one of the best methods that people use to understand what is happening, not only at the surface but also at the deeper levels. So we'll look at that in a little bit more detail. The second group of techniques that I'll be focusing on are basically using acoustic waves or what we call seismic waves. So if you have studied earthquakes in the past, especially in Geology 110, you may have studied like body waves. So how basically the knowledge of body waves and surface waves, you can use that knowledge to identify different rock layers in the subsurface, understanding the different interior layers of the earth. So I do have here a seismometer with me. Have you ever seen a seismometer? So we'll be studying like how seismometers like this can be used to record earthquakes. Up here, this is just a small example of what we call geophones. So I do have a collection of geophones, as you can see up here. And so this is a seismic data collection system, and we'll try to like use this system to basically collect the seismic data and trying to understand, okay, how can we identify different rock layers in the subsurface. The other group of techniques I'll be focusing on basically shallow geophysical methods, so like resistivity surveys and ground penetrating radar surveys. So I do have here, so this is a radar transmitter. So it transmits radar waves in the ground and it basically collects the ones that are reflecting back from the rocks. So we'll use this instrument. So as you can see up here, this is not a bike, but this is a GPR survey instrument. So we'll use this instrument to understand how radar waves can also be used to identify shallow geohazards, like even like finding a sinkholes or even the location of like just pipes or caves that are very close to surface. So we'll do that, and finally in the later half of the semester, I'll focus on different remote sensing techniques. So like now, like satellite images are like very useful resource when it comes to understanding the surface processes that are happening nowadays. So we look at the optical satellites, we look at the LiDAR, and we could look at the microwave based satellite images, like how they can be used to interpret different geologic processes or even the ground deformation. So that is going to be kind of like the overall flow in this of content in the class. So I just wanted to briefly talk about like how I plan to conduct this class in the fall. So this class has two major components, so lecture and lab. So I plan to conduct lectures online, so I'll be posting lectures asynchronously online, which means that these are like not live sessions, but I'll post lectures maybe over the weekend, so you'll have the opportunity to look at the lectures before getting on campus during the weekdays. So regarding labs, so we'll be meeting on campus every Monday and every Wednesday of every week throughout the semester. So Mondays we'll be meeting in like SC 274. So again, most of you know where this room is located. So the main goal on Monday is to do some in-class activities. So whatever you studied in the presentation, we'll be doing like solving problems, solving equations. So we'll do that on Monday. On Wednesdays is where we have like a lab time or field visits. So Monday we'll be meeting here in SC 125. So again, if you have not seen SC 125, this is the room. So if you have taken Julie stratigraphy class, you know where this room is located. So this room is located in the ground first floor. So again, we'll be meeting here every Wednesday because this is where most of the equipment is. We'll take the equipment out on campus, and if there might be some cases where we have to go off campus, so we'll load the equipment in the cars and we'll go off campus to do the surveys. So that will happen every Wednesday. So just remember that lectures will be online. There might be some lectures where I cannot do them online. I need to be on campus for that. So we'll utilize Mondays to do those lectures on campus. But on Wednesdays, obviously, like I said, we'll be doing like most of our lab work. In this class, I do have some field trips planned. So we'll be visiting two places. So one of the facilities that KGS has in near Lexington, and Wright State University, where they have a big geophysics program. So they're planning to do some experiments on their campus. So we may join them to do some experiments together. So again, all these things are, we have talked about it, but things change nowadays with this virus situation. So I will keep you updated on that. We do have like one or two companies coming to campus and giving us a workshop about how to use some of the geophysical equipment that they're using for their surveys. So hopefully that goes well in the fall semester. So again, I just wanted to give you like an overview of this class. So if you have any questions regarding the syllabus, if you have any questions regarding qualifying for this class, because there's a prerequisite, and if you want to like talk about that, please send me an email. If you already have access to this class, if you already have registered for this class, and if you have access to Canvas page, I have uploaded syllabus on the Canvas page, so you can look at this. I completely forgot about one thing, that for this class I'll be using this book. So this is called as a Field Geophysics. I think it costs $35 to $40 on Amazon. It is a really nice book. It gives you like a general overview of most of the techniques that we'll be discussing in the fall semester. This is not a compulsory book, but it is recommended to have this book, especially like if you want to have a career in geophysics or in geology in a long term. So remember that this book is really useful for this class. There might be some things that are not covered in this book, like remote sensing. So I'll make sure that I'll provide notes and other materials to you when we start discussing those topics. So that said, I think I'm gonna stop here. So again, if you have any questions, please send me an email, and I'm really excited to see you back on campus this fall. In the meantime, enjoy your rest of your summer and take care. So bye.